Hi, we left off with adding vectors, and you had some practice with your supplemental notes in class. Now we're just getting into some questions that you should be able to answer. So just a reminder, a vector quantity has magnitude and direction. So here's some questions you should be able to answer. I know one of the periods you guys got through these. It's a question, a car moved 80 kilometers to the south. What is its displacement? And that's 80 kilometers to the south. It went in one direction. Question two, a car moves 60 kilometers east and 90 kilometers west. What's its distance? Remember, distance is the total um, distance covered, okay? So you'd go 90 and then you go 60 kilometers, you turn around, you go 90 kilometers, you add those together and you get 150 kilometers. Now, a car moved 60 kilometers east and 90 kilometers west, similar to the question before, but what's its displacement? Well, now it's going one direction, turning around and going further in the opposite direction. So you subtract them and then you say which direction they would ultimately end up going from home. It's always from the starting position, and that's 30 kilometers west. Okay, so remember, I've taught you guys the triangle used for speed. So again, if we wanted to figure out speed, we can cover this S up, and it would be distance divided by time. Well, velocity is similar, but velocity includes direction. So we always do the magnitude or the size of it and the direction. So velocity is displacement change divided by time. So the change in displacement or the overall displacement. So you can write this, go ahead to your equation sheet that you had before, and I'm going to go ahead and add that to mine, and we're going to do another triangle. So I would write out V equals D divided by T, and write D is displacement, V is velocity, T is time, and go ahead and add that triangle. So instead of the S here, it's going to be a V, very similar to the other one that we did in class for speed. Take a minute and get that written down. Okay, again, concentrate on that triangle. You cover up the thing you're looking for. If you're looking for distance, you would put a finger over this D, and it'd be V times T. Velocity times time would give you the distance. All right, so I really want to focus in here. Speed only describes how fast something's going, but if you know the direction and are including the direction, then you're talking velocity. So it includes the speed of the object and the direction of the motion. So if you were to look at a race car going around a racetrack, then you can see from this picture that their direction is constantly changing. So their velocity is constantly changing. So even if the speed remains constant, which is what they're saying here, they're saying constantly going at the same speed, the velocity is changing. So that's why we're going to deal with straight lines. All right, I wanted to take a break here, and you guys can write down 2 facts on the back of your daily log about this video of the physics of skateboarding. And we're going to hit upon more of these, but I thought it would be a good break after you guys learned about velocity and speed. And then it will also be introducing you to some new things that we'll be talking about.